Okay, so we've got engraving, we got the profiling. Now, let's go ahead and do that. See, we got more room. Let's go to the program tab. Now, excuse me. Now we're going to machine this screw-like pocket. And we're going to use some of the advanced 4-axis methods. And we're going to finish, as you can see, we got curves at the base of that pocket, right? And then we got curves that are offset, and we actually have another surface right here. So the reason that we created this surface is that we don't want to go all the way to this edge, because we're going to use a 4-axis profiling operation to clean that edge perfectly. So we want we're going to use drive surface machining, 4-axis. So we want it only go to a certain distance away from the part. Typically it could be the tool radius, but not less or not more than the tool diameter. So we've got approximately the tool radius here, and we just rough that in up there. It doesn't really matter what that shape is, as long as you're not on the curve, and also that you're backed up enough so you can get a clean up with that profile. And it's the same on this other side over here. Okay. So
quick note about this method. This is, you know, I did mention all the other 4-axis methods that we have in the expert configuration. If you go use that drop down on 4-axis down, yeah, those are all the different methods we have in the expert configuration. And if you notice, drive surface is the last operation. This is really the only operation that we have that really is true 4-axis, in the sense it's not a wrap operation. So we're not taking one of the linear axes, in this case the y-axis, and converting that to a rotary. And drive surface, all 3 axes plus the rotary axis also will change. And the way we do that is basically taking the drive surface, and I'm sorry, I have to correct myself. Even in drive surface machining, one of the linear axes is mapped to a rotary axis, but the way we define the drive geometry is different. You know, it's not projecting onto that cylinder or rotary axis. We actually have to create a drive surface, and we're using the ISO lines of the drive surface to create the toolpath. So that's what Don's going to be showing now. So.
Okay, so we're going to go, while this is up, we're going to go ahead and pick drive surface and get this up on my other screen here. So for the surface, as I mentioned, let's go ahead and use a select surface. And I'm going to pick the surface here that I created. It's actually on this, you know, the final finished surface. So it's just not extended all the way out to the edge. So we've got that surface selected, and let's go ahead and pick our tool. We're going to go ahead and we'll use the 188. Okay, and we'll go look at our cut parameters here. So we've got 1,000 tolerance, a stock of 0. This is a finished cut, and we're going to go across. So the tool is going to wrap around similar to that facing operation, but it's going to stop within the perimeters of this surface. Okay, and then also we're going to go low to high. That's fine, and we'll increase this to 75%. And let's go ahead and run that. Okay, so that was pretty fast. So the tool is going around the axis like this. Let's go ahead and simulate that. So the tool is on the bottom of that pocket, and the center of the tool is stopping at the edge of the surface, or the perimeter of the surface. So basically, we're finishing it on the cylinder, but we're roughing it on the side walls. You can think of it that way. Okay.